welcome to today's video on how a binary adder works. I am Dr.S.Rizwana Begum, Associate Professor, PGM Research Department of Physics, Sithalakshmi Ramaswamy College. Binary adders are an important logical circuit which must be known to know how computers work and how they perform arithmetic operations. Let us see what a binary adder is. A binary adder is a digital circuit used to add two binary numbers. The input of this circuit will be the two numbers that we want to add, and in the circuit will generate the sum of those two numbers along with the carry. This binary adder circuit can be designed using half adder and full adder circuits. Now let us see what a half adder is. It is a logic combinational circuit that is used to add two 1-bit inputs to generate their sum and carry as output. The figure shows the block diagram, truth table, and the logical circuit of a half adder. From the block diagram, we could see that when we give A and B as input, we get their sum and carry as output. From the truth table, you could see that when 0 and 0 is added, you get a sum equal to 0 and the carry will obviously be 0. When 0 and 1 is added, you will get the sum as 1 and the carry as 0. When 1 and 0 is added, you will get 1 as sum and 0 as carry. When 1 and 1 is added, you will get a sum equal to 0 and carry will be equal to 1. From the truth table, here the sum is equal to the truth table of an XOR gate and the truth table of a carry is equal to the truth table of an AND gate. That is how the logical circuit is designed. Here is the logical circuit of a half adder, where this is an XOR gate, this is an XOR gate, and here it is an AND gate. So this is how a half adder works. Now let us see the working of a full adder. Full adder is a combinational circuit that is used to add three 1-bit inputs and generate their sum and carry as output. A, B and C are the three inputs and sum and carry is the output. This is the truth table of a full adder, where you could see that when all the inputs are 0, sum is 0, carry is 0. When any one of the input is 1, as the case that is shown here, the output will be sum is 1 and carry will be equal to 0. Now comes the special case where two of the inputs are 1. That is, when you add A0 along with B1, we will get an output of 1, which is again added with C, which is also 1. 1 plus 1 will give you 1, 0. So 0 will be the sum and 1 will be the carry. This is the case of here you could see that A is 1, B is 0 and C is again 1. So we will get a sum equal to 0 and a carry equal to 1. The case is same for A equal to 1, B equal to 1 and C is equal to 0. Where when you add A and B, you get carry of 1 and a sum of 0. Then comes the case where you have all the three inputs as 1. So 1 plus 1 will give you 0, 1, which is again added with the value of C, which is also equal to 1, so that you will get 1, 1. Here sum will be 1 and carry will also be equal to 1. From the truth table of a full adder, the logical circuit is designed using a K-map. From the K-map, the sum is obtained by using two XOR gates and the carry is obtained using two AND gate and a OR gate. So this is how a full adder works. In the next slide, we shall see how a binary adder works. So now we will see a 4-bit binary incrementer. What is a incrementer? An incrementer will increment a binary number by 1. Suppose we have a number like 1011. So this number is my A0, this is A1, this is A2 and this is A3. We want to increment this number. So what we will do? We will add 1 to this binary number so that when you add these two, A01 and this 1, you will get 0 and you will get a carry of 1. So 1 and 1 when you add, again you will get 0 and 1. So this 1 and 0 will be added, you will get 1. Here this A3 will be the same 1. So this is the increment of the 4 binary number 1011. So the same operation can be implemented using 4 half adders. Yes, you can use 4 half adders to get the increment of a 4-bit number. So here the number that we have chosen is 1, 1, 0, 1. So the first half adder will have this particular operation. So 1 is given here, 1 is here. So 1, 1 are inputs to the half adder. So definitely the half adder will add these two numbers and it will give an output of 0 and 1, carry 1. So this carry will be taken to the next half adder as the second input. So here 1 goes here so that the second half adder will have an input of 1 and 1, which will add those two numbers and give a sum of 0 along with the carry of 1. So this carry is taken to the next state and here the input becomes 0 and 1 for the third half adder, which adds these two numbers and gives a sum of 1 and a carry of 0. So this 0 is taken to the next half adder where the input of the half adder becomes 1, 0 and when it is added the sum will be 1 and carry will be 0. So the same result is obtained. So this is how a 4-bit incrementer works. A 4-bit binary adder is a combinational circuit used to add two 4-bit numbers. The input will be the two 4-bit numbers. Again, the output will be the sum and their carry. Now, we shall see the working of a binary adder. Before getting into the working, we shall see about the binary addition of a 4-bit number. So the first number, let us name the number as A0, A1, A2, A3 and let us have the second number as B0, B1, B2, B3. And when you add these two numbers, you will get the sum as 0. If it has a carry, then it will have a carry C1. When you add these three numbers, you will get the sum as S1. The carry will be C2 and here it will be S2. Carry will be S3. Here S3 and you will have carry S4, C4. So the same operation can be performed using a circuit which is called as binary adder. So for the first case, you could see that we have only two numbers A0 and B0 to be added. So it is enough we use a half adder. But for the rest of the bits, you could see that we have three numbers carry A1 B1, carry A2 B2, carry A3 B3. So we have to use three full ladders for that operation. Let us have an example and see how a binary adder works. Let us take the first 4-bit number as 1101 and the second number as 1011. So here A0 is 1, B0 is 1, A1 is 0, B1 is 1, A2 is 1, B2 is 0, A3 is 1, B3 is also equal to 1. So when you add the first two numbers 1 and 1, you'll get a sum equal to 0 and carry will be equal to 1. So sum is equal to 0, carry will be equal to 1. So this 1 goes as input to the next full adder. So 1 plus 0 plus 1 is again 0 and 1. So here the sum is equal to 0, carry is equal to 1. So this carry goes as input to the second ladder. So 1 plus 1 is 1 0, which is again added with 0 will again give you 0 and 1. So here also the sum is equal to 0 and the carry is equal to 1. The last full adder has all its three inputs to be 1. So A's carry is 1, A3 is 1, B3 is also 1. So it will give an output of 1, 1. So sum will be equal to 1, carry will also be equal to 1. So the same operation has been performed. This is how a binary adder works with half adder and full adder. Now we shall see how binary adder works using a full adder. So here to design the circuit we use 4 full adders like this. So as we already know, we have to add two numbers, that is A0, A1, A2, A3 along with the next 4-bit number B0, B1, B2, B3. And the first number here for the full adder, we require 3 inputs. So we are going to take the first input, that is the carry input, as 0. Carry input as 0. And we are going to add C0, A0, B0 to produce an output S0 and the carry C1. So second full adder will have the inputs as C1, A1, B1 and it will produce a sum of S1 along with the carry C2. Then the third full adder will have C2, A2, B2 as their input to produce a sum of S2 along with the carry of C3. So when the final full adder adds these three numbers, you will have a sum is 3 along with the carry 4. So this is how a 4-bit binary adder works with a full adder. So the first case, let us have an example and see how it works. So 110, 1110 along with 1101. So now you could see that the first A0 is 0, B0 is 1, A0 is 1, A1 is 1, B1 is 0, A2 is 1, B2 is 1, A3 is 1, B3 is also equal to 1. So here the n is given because you can increase the number of the full adders depending on the n number of bits. Here we are talking about 4-bit binary adder. If you want 5-bit, you can have 5 full adders. If you have 6-bit number, you can increase the full adders. The full number of full adders will be n and n will be the bit number also. So when you add, the first input Cin will be equal to 0. So 0 plus 0 is 0, then 0 plus 1 is 1. So S0 here it will be 1. So carry will be equal to 0. So S0 is equal to 1, carry is equal to 0. Carry is equal to 0. So this becomes the next input. So 0 plus 1 is again 1. carry is equal to 0. So here also it is equal to 1, carry is equal to 0. So for the next case, 0 plus 1 is 1, 1 plus 1 is 0, 1. So here it will be equal to 0 and carry is 1. So this carry moves to the next case. So where 3 inputs are 1 and you will get the output as 1 and 1. So this will be the carry. So here carry out is 1, S is also equal to 1. Here the thing is S3. Here it is S3. If you have 4, you will have 4 like that. So this is how a binary adder works using full adder. A 4-bit binary adder also is designed using as a integrated chip number 7483. The chip 7483 operates is shown here, where the two 4-bit numbers are given and the chip will produce a sum and it will produce a carry. It has also an carry input. So for the first case, you will give the input as equal to carry input equal to 0 so that it produces the correct output. So this is how a binary adder works. Thank you for watching.